Hey there guys, my name is Rob. As you all know, finals are coming up. What a pain. We all gotta get through it. The best way for that is just to study. Luckily for you, studying won't be that hard. If you're having a problem catching on to that math type of stuff, then perhaps I can lend you a hand. On today's lesson plan is to explain to you a concept that many people find pretty difficult. I can see that you already have a visual of what it's gonna be on today. Yep, yeah. Series and sequences. Let's go. We're gonna start off with the simplest of sequences to get an idea and a feel for how all this stuff really works and really comes together. Even this little fella here can do it, so there's nothing to be afraid of. Come with me on this trail to begin our first concept of arithmetic sequences. Woohoo! So this is how they generally work out. You have a series of numbers. For example, you have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus... Doing this all the way up to 100 is way too overwhelming. There's got to be an easier way. Let's begin with noticing a few patterns within this series to see if whether it is actually arithmetic or not. To figure this out, you have to look for the common difference. The common difference is the difference between two consecutive terms. And here we take the 2 and subtract 1 to get a difference of 1. To see if this series is actually arithmetic, we need to find the same difference between two other terms. Let's go ahead and take this 5 and 6. So then we need to subtract 5 from 6 to end up with a difference of 1. Can you see the similarities? But there's still more I have to show you. So let's keep on traveling into the wonders of these series. Oh, and my apologies, that 8 right there is supposed to be a 6. So let's get back to business. So how do we know what's in between that 6 and 100? That's the real question. Is there any way, shape, or form we can figure this out? There actually is. We can use this arithmetic formula where to the far left, Tn is the term you are looking for in a series. The T1 is the first term of the series. Inside the parentheses, the n minus 1 is the term you are looking for, minus 1. The D represents the common difference. So with this formula, you can find any term within that series, or any of those ... dots. Let's go back to our first series. As you can see, it's very long to write. How can we possibly shorten all of this? And thus, I introduce you to sigma. This here sigma shortens all that plus 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 into one simple form. This is how we condense it. Since the final term of this series is 100, this 100 goes on top of the sigma. So what goes at the bottom represents the series starting point, written in the way of n equaling 1. Last is this n to the right here that represents the typical element of the series, in this case being 1n. And that's how we shorten an arithmetic sequence. So we can put an end to all this plus plus plus. But arithmetic sequences are only the half of it. Now let's take a road down to a new concept. Yeah, you've just entered the new world of the geometric sequence. Although at first glance may look like an arithmetic, take a closer look at those patterns and you know it's not. So let's take a close look at this example. Again, we got 1 plus 2 plus 4 plus 8 plus 64. Again, it's very overwhelming to be writing all this plus plus plus. So what can we do? Looks like we have to start from the basics again. Let's start off by figuring out how to find what's inside this ... again. So again, luckily, we have a magical formula that can figure out the mysteries of the dots. Where to the far left, the Tn represents the term you are looking for in the series. The T1 represents the first term of the series. The r is the common ratio, where the exponent n minus 1 is the term minus 1. So we know how to get all that mumbo jumbo that's in the middle. Oh, so that thing I mentioned earlier, common ratio? What it actually is the ratio of a term to the previous term, as the following. 4 over 2 equals 2. Another example would be right next to it. 8 over 4 equals, well, what do you know? 2. Now going back to sigma, how do we make this shorter? Well, first we go to our nth term formula where Tn equals 1 times 2 to the power of n minus 1. The initial and final values of n are obtained by substituting the values of the first and last term in the general expression for the given series. We'll substitute the first term with Tn. So 1 equals 2 to the n minus 1 power. Then n minus 1 equals 0. Then n equals 1. Let's now substitute the last term for Tn. Last term being 64 to equal 2 to the 6th power to equal 2 to the n minus 1 power. Solving for n minus 1 equals 6. Hence n equals 7. Now we can shorten all this writing with the use of sigma. Having only 7 terms, we put 7 on top. 1 being the first term of the series goes on the bottom, hence n equals 1. And to the right we have the typical element, 2 to the n minus 1 power. And that's how we minimize geometric sequences. Writing a series in a different way is one thing, but to actually add it together is another. Now it's time for sums of arithmetic and geometric series. So let's begin adding arithmetic series first. Doing this, we use the formula Sn equals n parenthesis t1 plus tn parenthesis over 2. And with this formula, we no longer have to write the 1 plus 2 plus 3 plus 4 plus. Instead, we can now choose up to which term we would like to add. Let's just say 15. Using substitution, we insert 15 parenthesis t1 plus t15 over 2. Now we go down. More substitution. Now we begin to solve it out. A quick calculation. So in this series, terms 1 to 15 add up to 120. Now we gotta get back to adding that geometric series. A little different from arithmetic, but the formula is Sn equals T1 parenthesis 1 minus r to the nth power parenthesis over r minus 1. R equals 1. No, it can't. Not in a geometric series. So in this series, I've decided to add up the first 5 terms. I've already substituted into the formula, so this is what I got. And continuing on, we get S5 equals 1 plus negative 32 over negative 1. So the terms in that geometric sequence from 1 to 5 added up to 31. Congratulations! You just learned a thing or two about series and sequences. The journey was rough, but when you come to think of it,